Hello and welcome to the On Teaching Math video that's going to teach you, teachers, how to teach square roots conceptually. This is a brand new series on my channel, and the series is devoted to helping teachers learn how to integrate some conceptual ideas and some practical ways to get students to think conceptually into your lessons so that you can kind of break away from that just teaching procedure and students just focusing on procedures and steps. The idea is that if students understand conceptually, their retention is going to be better, they're going to learn new material more quickly, and they're going to understand what it is they're learning now correctly because they'll have conceptual understanding. So with that said, let's go ahead and get started. So to teach square roots, what we're going to do is we're going to teach them 5 key concepts. And from those 5 key concepts, we're going to determine or we're going to develop some procedures that are a consequence of those. As the students work through those procedures, they're going to make the same mistakes they always have made, even if the concepts weren't ever exposed to the students. But as they work through, we're going to revert back to, we're going to validate procedure and we're going to validate answers by reverting back to those key concepts. And once it's all said and done, by integrating the procedure and the concept together and having them work hand in hand, students are going to come away with a much better understanding. So let's see how we're going to do that. So we're going to start off by first just giving you a brief overview of what those 5 key concepts are, and then we'll get into how to break down the entire unit, which will probably take about 2 weeks. So here's our 5 key concepts. The first key concept is that square roots, they're just numbers. It's valid to think of a square root as an operation, and there certainly is times where that's more than valid. It's absolutely 100% appropriate. But students need to see square roots as a number. The square root of 5, that's just a number. And all square roots have a property. That is that if you square that number, the product is the radicand. The second idea we want students to get their heads around is that because square roots have that property, we can read square roots as a question. So the square root of 5 can be read as, hey, what squared is 5? If a student can answer the question, then they can simplify the square root. Now the third key concept we want students to understand is why the square root of 9, for example, is equal to 3. We want them to understand why the simplification works and how to know if they're correct or incorrect. Our fourth idea is that a lot of square roots are irrational numbers. That means they cannot be written as a ratio of integers, nor can they be written as a decimal. The square root notation is the most concise and clear way we have of writing a lot of irrational numbers. The last idea, the 5th key concept here, it has to do with arithmetic between rational and irrational numbers. Students are going to have a hard time understanding this because in the past they've learned how to approximate, which is perfectly fine. That's a good skill to have. But when they do arithmetic with those approximated numbers, what ends up happening is those approximated numbers become rational, and then all the arithmetic works just like they're used to. And so there's a little bit of a disconnect here that can be difficult for students to correct. And this unit is a really good opportunity for us to help our students to understand this more accurately. So now let's get into the actual pace of the unit and what we're going to be doing on each day. So on the first day, what we're going to do is we are going to actually teach the students, we're going to introduce to them all 5 of those key concepts. We don't expect them to master these concepts yet. We just want them to be, I guess, referenceable would be the best way to say it. We want them to understand what we're talking about when we say, hey, did you read that square root like a question? We want them to have a reference of 5 key facts that we're going to revert back to, that we're going to use to develop procedure and then validate procedure. So the very first one, the very first key concept is that square roots are numbers. And the square root numbers have a very unique property, and that is that if you square that number, the result is the radicand. So of course we need our students to understand what the radicand is and what the radical symbol is, but those are of little consequence. Those are pretty easy for kids to get. But just to be explicit, we want students to understand that if you take a square root number, like the square root of any number, and you square it, the product is the radicand. That is the key idea. That's a little elusive for students, and they don't actually think that this is math yet because they haven't seen any steps. So a question that you can ask that can help students to get their head around what this really is saying is this question right here. It says that if k is equal to p squared, what is the square root of k? Now, what they're going to see what you're going to see with the second key concept or the key idea is that we can read a square root like this as a question. This says, hey, what squared is k? And it tells us here, p squared is k. So p is the answer. But we can also look at it like this, using our first fact, that if you have a square root number and you square it, the answer or the product is the radicand. And we're also given the fact that if you square p, the product is k. So if you have the square root of k and you square it, the product is k. If you have p and you square it, the product is k. So that means that it must be equal to p because they have the same exact property. So the square root of k must be p, right? Okay, now, item number 2. We want students, when they see square roots, to think of a question. We want them to think, like for this one right here, the square root of m, we don't want them to just, of course they're going to say the square root of m, but we want them to think, what squared is m? And if they can answer the question, then they can simplify it. If not, then they can't. So like this one, for example, square root of 4 is really asking what squared is 4. If they know the answer is 2, then they're good to go, right? The square root of 24 is where we're going to start getting into a little bit of trouble, and we're going to get into that here pretty quickly. But the square root of 24 is 2 root 6. And we want students to know why that's true, which brings us to our third key concept. We want them to know why a square root simplification is correct. Now, our very first idea is that if you have a square root, you have a number, like the square root of 9, and the property is that that square root number squared is equal to the radicand. So the square root of 9 squared equals 9. 3 has that same property as the square root of 9. If you square 3, you also get 9. They're the exact same number. The square root of 9 squared is 9. 3 squared is 9. They are the same exact number. 9, the square root of 9, and 3, 100% the same, and that's why. When students simplify, for example, the square root of 25 to get 5, it's right because 5 squared is 25. It's not right because of any steps or any other reason whatsoever. We need students to understand that when they simplify a square root, they are either addressing our first fact that a square root number squared is equal to the radicand, or they're answering the question that just rewords that same principle, and that is, what squared is a radicand? Those are the only two reasons why simplifying a square root is right. We've got to get our students to understand that very, very clearly. So the reason, for example, that we know that the square root of 24 is equal to 2 root 6, well, is because 2 root 6 squared is equal to 24. So if they can show that that's right, then they're good to go. And that brings us to our fourth point, and that is that the square root of 6 is irrational, and irrational numbers behave differently than rational numbers do. So the square root of 2, students are probably okay at approximating it as 1.4, just like they're okay with approximating pi as 3.14. The problem is that they really do misunderstand. They think pi is close to 3.14, and that's it. Like, if they had enough time or space, they could write it out and they'd be good to go. They don't understand that the reason we use the symbol pi is because we can't really come up with a better way of writing the number that is the ratio of a circle's circumference divided by its diameter. And the square root of 2, we don't have a better way of writing the number that's squared is equal to 2. So we use these notations instead. They're irrational, which means we cannot write them as, well, a ratio of integers. We can write them in a fraction, like the square root of 2 over 2, but we can't write them as a fraction. And we also cannot write them as a decimal. Anything we try, any way we try to write the square root of 2 as a fraction or as a decimal, is we're writing an approximation. And one of the key properties of the square root of 2, or pi for that matter, is lost the moment we make an approximation. The approximations are rational, and the arithmetic is different. And that brings us to our fifth and final idea, and that is that when you multiply a rational number with an irrational number, your product is irrational. We can't actually carry this out any further because we don't know what the square root of 2, we don't have another way of writing what the square root of 2 is any better. So we need our students to understand how the arithmetic with rational and irrational numbers works. And we can give them some simple examples like squaring 2 root 6, for example, to get 24. However, in the first day, we want to give them a bullet list like these 5 things right here. This poster could maybe even be printed. The screen could even be maybe printed and used as a small poster that they could refer to over the next 2 weeks. Because as they work through and they get confused or they get stuck or if they're not sure of correctness, we're going to be referring back to these 5 key concepts. Okay, so that would be day 1. And again, we're not expecting them to master these things in any way, shape, or form. We want these things to inform their procedure. And then when they're working with the procedures and they get stuck or they start doing something wrong, we're going to revert back to these again. And through intertwining procedure and concept, we're going to come away with the procedural proficiency we need and the mathematical literacy that we also need because they're going to be working together, hand in glove. That's how it's going to work. So let's talk about getting into the actual instruction of how to deal with some square roots now, right? So day 2, we're going to start actually doing, according to the students, what looks like math, right? So I would start the day off by asking a question kind of like this. Why is it that the square root of 16 is actually equal to 4? And we're looking for students to have a justification with 2 parts. And we need both. We need them to articulate both. And it has to come from them. If we give them this information, then they're not grappling with what it is they understand. And they might be able to recite it, but it's not really integrated. They're just parroting. They don't really understand. It's kind of like learning a phrase in a foreign language, but you don't really know the language. So the 2 parts we want students to state that square root numbers have a property, and that is that if you square them, you get the radicand. So square root of 16 squared, 16. Second thing we want them to say is that the number 4 has the same exact property as the square root of 16, and that is that if you square the number 4, you get 16. So those 2 numbers are the same. Now, the next thing we're going to talk about in the second day is, well, using the question from the second idea to simplify a square root. This square root right here, the square root of 25, it's asking what squared is 25. And students should know their square numbers up to 400, and they should be able to very easily say, 5 squared is 25, and they should be able to answer that. Now, once they've got the idea of how those square roots of square numbers works, instead of just telling them how to handle something like the square root of 24, which they'll try to follow and understand, but they're going to lose sight of it, it's probably better to ask them why the instructions would be said like this. So, of course it says to simplify a square root, you got to factor the radicand, find the largest perfect square or the largest square number. So if you have students justify that by reverting back to what they understand from the first 2 principles, well, then they're going to have better understanding of the purpose, and hopefully they won't be making quite as many mistakes. Because you see, when they see the square root of 48, they should know, hey, that is asking a question, what square root is 48? The problem is that when they factor 48, they almost always settle on 4 times 12. Because they didn't factor and find the largest perfect square. The reason that we want them to find the largest square number is because it addresses the question that this is asking. This is asking what squared is 48. So we're looking for squares. We want to find the largest because it's simplest. So the second thing we want to do on the second day is we want them to be able to verify that this is correct. So we want to teach them how to multiply 4 root 3 times itself to get 48. Right? And we're going to do that, and then we're going to be pretty specific about our instruction here. We're going to show them that when you multiply numbers like this number here is irrational, but it has a rational component and an irrational component. What we do is we rearrange it. So we multiply the rational parts and we multiply the irrational parts. And 4 times 4 is 16. Square root of 3 times the square root of 3 is just 3, which makes 48. That's why it's true. And so in the second day, we want our students to really have a good understanding of that. Now, Another piece of very specific advice we can give our students would address this mistake right here. So what's actually happening is students are not recognizing square roots as numbers. They're seeing square roots as an operation. And so what they end up doing is this right here. They end up saying the square root of 16 times 3 is 3 times the square root of 4. And when they describe it, or they describe their mistake, they say something about taking a number out, or, something like that. And that language is very, very divergent from what it is we're dealing with here. We're dealing with square roots. And if we want them to be thinking about square roots as a question, this here does not answer the question that's asked by the square root of 16 times the square root of 3. And so to help avoid that, one piece of advice that we can give our students very specifically is when they're factoring the radicand, when they're factoring the square root number, to write it as the product of the largest perfect square, the largest square number, times whatever's left over. And then all they've got to do is read it. This says, what square root is 16, which they're going to know is 4, times the square root of 3, which they can't rewrite, so that's why it's going to be 4 root of 3. This little step right here versus this up here can really help keep them out of trouble. All right, so now day 3 is just more practice. We want them to start working with exponents, and we want them to be checking. But day 3 is not really new information. It's just an extension of what they learned in day 2. Now, let's move on to day 4, shall we? In day 4, what we're going to have them doing is we're going to have them still simplifying square root numbers whose radicands are composite, but they're going to be multiplying that with a coefficient like 4. I guess it's not really a coefficient, but with another rational number. And so what students are going to end up doing here is they're going to say, the square root of 48 is 4 times the square root of 3, and 4 times 4 is 16. And then they're going to be thinking, oh my goodness, I've been being harped on forever about 16. Square root of 16 is 4, so they're going to write 4. And they may even continue that even farther and say that the final answer is 2 times the square root of 3. When they do that, they have completely lost sight of our very first principle, and that is that square root numbers have a property that when you square them, you get the radicand back. When you square 4 times the square root of 3, you get 48, but you don't get 4. But this is 4 times the square root of 48. So this and this are not the same thing at all. We also want them to be able to manage and deal with square roots with exponents and variables. This is a square number. This one we will consider prime because we can't factor it except 1 times itself. And so we want them to be able to handle those kinds of things. We also want them to be able to handle things like 5 root 2 plus 7 root 2, which would be 9 root 2. And we want them to see that these are the same, that these last 2 examples are the same. And that's going to get us starting to deal with the order of operations. One good question that we can start getting our students to address, and we should be very careful in trying to get them to address it, not us addressing it for them, is why you can add the square root of 5 times the square root of 2 with the square root of 7 times the square root of, or 7 times the square root of 2. Because multiplication comes before addition in the order of operations, and there's clearly multiplication going on here between a rational and an irrational number. So why is it that we can add? And students are going to say, because it's like terms, but they still don't really understand what it is. And here's what it is. It's because multiplication is repeated addition. And so we can consider this first number as square root of 2 plus itself 5 times. And we can consider the second number as the square root of 2 plus itself 7 times. And since those two things are adding, we can add them all up ahead of time and get 12 times the square root of 2. Now, moving on to day 5. Day 5 is a continuation of what they learned in day 4. It's nothing really new. It's just going to get a little bit more complicated. Students are going to have to be simplifying the square root numbers and multiplying by the rational multipliers, and then seeing if they have like terms or not. So what we want them to be doing is finding things like this. So this would be, this would be 2 root 6. And this would be 3 root 6. And so this would be 10. This would be 21. So this would be 31 times the square root of 6. The idea here is that these two are actually like terms. They're just kind of hidden. On this last one over here, what we have is we have more than two terms. We actually have, or more than one set of like terms. We actually have a pair of like terms, and we want them to be able to manipulate this, to rearrange the order so that they can combine like terms correctly. And the last thing we're going to be talking about, again, very strongly deals with the order of operations. If students can follow the operations correctly here, this is actually no problem whatsoever. But the thing is, we have to encourage them to revert back to using the order of operations correctly in order to be able to simplify something like this. And so, as you can see, even though we're teaching square roots, there's a whole lot of stuff coming out. We've got arithmetic between rational and linear rational numbers, and we also have a lot to do with the order of operations. Now, day 6, we can start getting into division, into reducing, and rationalizing the denominator. Now, a lot of people, they don't like to teach rationalizing the denominator. And I think that's really a little too bad because, well, one of the reasons people don't like to teach rationalizing the denominator is because it seems tricky for students and it feels useless because we have calculators that'll do it for us. The problem is the things that make rationalizing the denominator tricky, those concepts are really 5th grade concepts. And so if we allow our students to go through high school and have less than firm footing with 5th grade concepts, math is going to be a roadblock for them in the future. And that's really not, at least for me, I'm not here to just get through this year. I want the students to be well prepared for the future. And so I cannot in good conscience let them just slide through without addressing those kinds of misconceptions as well as I can. So I want to address them, and teaching rationalizing the denominator is a great way to start. So there's a couple key things that we need our students to have in the forefront of their mind before we jump into rationalizing the denominator. The first is that our first principle, square root of 2 is just a number. The other thing we got to get them to understand is that if you divide a number by itself, like even the square root of 2 divided by the square root of 2 is just equal to 1. And then the last thing we want them to understand is that when you multiply a number by 1, nothing changes. And so what ends up happening is when we try to take something like 1 divided by the square root of 2, and square root of 2 is irrational, and we want denominators of fractions to be rational numbers. So all we're going to do is we're going to use the first property we learned about square root numbers, and we're going to multiply that square root of 2 by the square root of 2. But we're going to multiply the whole fraction by the square root of 2 over 2, which is really just equal to 1, doesn't change the value. So this really should not be that big of a deal for students. I think it's completely attainable. Now, have them practice some of those things, have them review some of the whatever you find that they're having difficulty with up until this point. And really that's going to be it for day 6. On day 7, we're going to start trying to expose some misconception. We're going to try to move ahead. There's no new information at this point, but we want to make sure that the students are not just focusing on procedure. We want to make sure that they understand exactly what it is they're doing, what and why they're doing it, and why it's valid. And so I'm going to propose 2 groups of 3 questions each. And these questions or these expressions are designed not to confuse students, but to expose confusion that they might already have. So these questions might challenge them, and they might make them a little frustrated and confused, but that's exactly what needs to happen in order for them to learn. We want them to be confused and find resolution to that confusion during class, not on test day. So anyway, these 3 right here, the square root of 8 divided by the square root of 2, and 8 divided by the square root of 2, and the square root of 8 divided by 2. All 3 of these, they can simplify. Only one that they're actually going to have to rationalize the denominator for is this one. But if they jump in on the first one, square root of 8 divided by the square root of 2, and they just start rationalizing the denominator, if they do the reducing correctly, they will still get the right answer. And that will be a really good opportunity for you to discuss with the students what it is they missed and what it is that they could have done that would be a little simpler. And it's going to help them to understand basically the way arithmetic with square roots works better. The other set of 3 numbers are here right now. You got the square root of 8 divided by 2 root 2. You got 8 divided by 3 times the square root of 2. And you got 3 times the square root of 8 divided by the square root of 12. And once again, these 3 questions are very similar. None are very complicated. But when they do one and then the other and then the third, what ends up happening is they start second guessing themselves. They start doubting their procedures. And that's exactly what we want them to do. We want them to be thinking. And in order to do that, sometimes we have to slow them down. And so that would be it. For day 7, we're ready to move on. Between maybe doing a quiz after the first few days and a quiz or maybe a test after the last day here, then I think you can fill 2 weeks with very valuable mathematical experiences for your students. And I think as you move forward, you can start introducing more of this conceptual style of learning and weaving together concepts and procedures together. So let's go ahead and review how this works. We introduced the 5 key components or key concepts, and from that we developed procedure. And as we worked through procedure, we reverted back to those concepts for validation, and hopefully our students have come away just being fantastically, wonderfully enlightened and have had a positive experience from it. And very importantly here, that when they see square roots down the road, for example, when they're doing the quadratic formula, we want them to understand what those square roots are and understand how to handle them without having to reteach, without having to give them a whole bunch of prompting. We want them to be able to, on their own, recover what it is that's maybe a loose memory or partially forgotten memory. And they can only do that if they have a very solid conceptual understanding. So I'd like to thank you for your time. I hope you've enjoyed the video. I hope it's given you some ideas of how to incorporate concept and procedure as you start teaching square roots and even other subjects. If you want some more information on teaching square roots conceptually, if you go to my website, thebeardedmathman.com/podcast/E3, there's a podcast that deals exclusively with teaching square roots conceptually. There are some other episodes there that I would be very happy if you would take a listen to. Let me know what you think. Also, if you want some lesson plans and practice problems and resource materials for students on square roots that align with the principles and the flow that you saw in this video here today, you can go to my website, thebeardedmathman.com/square roots. And of course, these links will be listed down below in the description. Anyway, my name's Philip Brown. I am the Bearded Math Man. This was our very first episode of the On Teaching Math series. I hope you enjoyed it, and thank you for watching.